Okay then, so moving on, we have Carlos, who's going to be talking about EIPs that sound zkEVM scary. I don't know about you, but like zkEVM sounds scary enough to me. Hand it over to Carlos.
Thank you. Hate from everyone that is emotionally attached to any EIP or anything like that. I'm not in favor of or against any of the EIPs that are currently proposed. It's just trying to give an overview from the teams that are building basically zkEVMs on how the EIPs will affect us and how do we need to deal with them, and so that it can maybe open a new path on how we can envision the future for future EIP proposals. So quickly, the talk overview. The main idea is explain what proof of validity is. What does it mean that an EIP is zkEVM scary, if that's even a term? I just coined it like 2 days ago. The differences and trade-offs between building a proof of validity and building an L2. And finally, we will see some of the EIPs that I personally consider scary and some future open questions that I have. So the first thing, what proof of validity is? Well, first, proof of validity is just how we call to the fact that we can actually create proofs of all of the blocks that are added to the Ethereum chain, such that basically we can have some extra or enhanced capabilities on them. Some of them are the examples here. We can have like fast synchronization because we can just verify the latest proof, and we have already verified the entire chain, so we don't need to run the execution of all of the things. It allows us to basically even recurse over the proofs and finally get a really small state size. And also it gives like really, really good properties to light clients to actually verify the claims and the data that is coming from the fork nodes. So the things that basically are unlocked by a type 1 zkEVM are, aside from all of the things that we have seen in the previous talk, also things like proof of validity. There are tricks that we need to do. There are problems that we face. You have a kind of a tiny list here, but we will try to oversee a little bit which are the biggest issues that we've had. And for that, we need to go to the next section. What does it actually mean that an EIP is zkEVM scary? Well, first of all, we all know that changing circuits is a pain in the ass, and you can ask Zcash, for example, as they've done many transitions, not even in circuits, but also in proving systems, and they are really experienced on that, and they know how hard this has been. There's a couple of things that I think it's worth mentioning here. So, for example, EIPs are almost never considering which are the in-circuit implications of the proposals that they give. So, for instance, we can ask for absolutely whatever we want, but maybe in circuit what we're asking for is really unfeasible to achieve, or even impossible in some cases. Not only that, but if you even get into the discussion and mention something related to zero knowledge, most of the people will be like, this is not what we are discussing. We are just discussing additions to the EVM, nothing else than that. So it's a bit confusing. Aside from that, we also have the removal of features, or basically adding anything that relays on Ketchak or adds conditional execution, branching, or periodic length, is definitely something that we don't like to see from the circuit developing standpoint. So let's see the trade-offs of building a proof of validity zkEVM or building an L2, L3, or whatever. The first thing, and the most important one, is that if you are building proof of validity, you really need to implement every single detail of the Ethereum spec and the EVM spec. And that means you cannot just ignore precompiles that no one is using. You cannot ignore very complex opcodes or primitives. And you need to be up to speed constantly with all of the new hard forks that come. So if you don't develop your circuit fast enough, you will lose the sync on proofs on the latest blocks of the Ethereum mainnet, and then you will have an issue. On the other side, if you're building an L2 or an L3, you basically don't have this problem. You can just ignore whatever you don't like. Of course, at the exchange that your users will not have this available. But for things like RipMD or Blake2F, this doesn't even matter. Almost no one is using them. You can just switch the MPT for binary trees, and I know this is not something directly tied to the EVM, but it's in the Ethereum spec. And finally, they don't need to keep up with hard forks constantly. They can just deliver something a bit later and refine it and make sure that everything is secure and fast. So let's see one example about something that looks not so hard and difficult, but it really is a pain behind the scenes. We have Xcode size. So if we go to Xcode hash, which is a really similar opcode, we can just go to the MPT, look up the value, we're happy, we're fine, we have what we needed, and that's all. But it turns out that when we want the code size, the things get a bit bad, because the code size is not stored as a property inside of the MPT. So we basically need to count the bytes. It's not only about that, it's also the fact that we have a bytecode limit now, bytecode size limit of 24 kilobits, which we will see soon, it's an issue. And also, we need to consider the fact that the pricing of the EVM opcodes is not in line at all with the real cost in circuit of performing certain amount of operations. So we can, for example, see the kind of workflow that we implemented for Xcode size, like from an outer scope. We first need to witness all of the contract code bytes, which is fairly a big amount of witness already that we will need to commit to later. Then we need to copy and range constrain every one of the single bytes that is there. So we need to check that everything indeed is a byte and we're not tricking the system. We need to hash the entire thing. So that means we need to support up to 24 kilobit hashes, which are done with Ketchup, which is not circuit friendly at all. And then we need to go through the MPT, which means more hashing, search for the code hash, and we need to see if those hashes are equal so that we can basically make sure that the count that we have done of the bytes is indeed corresponding to what we think. So as you see, it's not really easy to do these things, but it's even more difficult to do these things being fast and being secure and performant and optimal. So the EIP proposals that I consider scary, there are hundreds of EIPs proposed every year, and between 1 to 15 make it to each hard fork. We can see some examples here, like BLS precompile, EVM, Ethereum object format, or Ethereum object model. And this is, for example, a list of all of the Cancun candidates that we have for the next hard fork. And as you can see, this is not small at all. So that means we will need to implement all of this stuff, or whatever is getting merged, inside of circuits to be able to keep up with the blocks that are coming to the chain so we can prove everything. I remember this needs to be secure, needs to be fast, needs to be optimal. There are cryptography-related ones. So for example, we want to add SecP 256R1, we want to have Poseidon, we want to have BLS, we want to have a lot of things. But all of this means you will need to implement it in wrong field arithmetic. So you need to support these fields, but emulating them with BN254 inside of a zk circuit. So for those who haven't done it, it's really, really, really tricky and painful, and it's really easy to screw up something here, turning into a vulnerability really quick. There's other things that are not cryptography related, and here we can see, for example, statelessness, we can see transaction package, we can see the Ethereum object format, there's a bunch of things. But generally, anything that adds conditions, anything that adds branching, variable length things, relying more on Ketchup, this kind of stuff, it's usually a pain. And that's why I, for example, agree a lot with the topic that we have seen in the panel previously about ossification, because if we get all of these things constantly being merged, it will be really hard for us to keep up to speed with our circuits, with what we currently have in the state of the art in Ethereum. So the future and open questions, and I just want to highlight one thing here. This is the RIPMD precompile. Here you can see an analysis of the calls that it has gotten. It has been basically called 1,317 times since Ethereum's inception. So that's almost nothing at all. And we can see kind of a similar thing from Blake 2F, which has been called 1,228 times since we had the Istanbul hard fork. So now the question is, do we want to remove those? Because no one is using them, so why would we need to have this? But the problem is, from the circuit perspective, we will need to implement and support these precompiles for all of the previous blocks. Now remove this thing and include the logic to support also the new errors that we need to throw out now that these precompiles are non-existent anymore. So the complexity just keeps growing and growing and growing, the more features we add and the more features we remove. So that's an important thing to highlight. So to finalize, I just want to put some list of future considerations that I think we should all think about and consider. The first one is, should we take into account zkEVM for EIPs? And what I mean by that is, if we are going towards ossification of Ethereum mainnet at some point, are we yet in a point where we are concerned enough such that we want to take into account zkEVM and proof of validity inside of the EIP discussions? Maybe yeah, maybe not, but this is definitely something worth reasoning about. Second, is proof of validity useful enough or desired? I mean, maybe we are really like obsessed with that, but it's not something that the majority of the community will make usage of, or it's not a useful enough tool for the main and broader audience that is running that. I don't think so, but it's up to anyone to have its opinion. And finally, are we in a rush? So, are we basically that much concerned, and do we really need to deliver now proof of validity such that we need to start restricting the EIPs that we merge into Ethereum? Or instead, we can just wait, see how everything goes, and then analyze in a few years and see what's the state of the art. Maybe we will find later that the things we have merged make it almost impossible to have an optimal prover for all of the things that we have already merged in the EVM. So that's the end of my talk. I don't know if I have time for questions, but happy to take them if there's time. And thank you, everyone.
Yes, you've been very succinct. You have about 5 minutes for questions, if anyone has any questions. Okay, we've got a question here in the middle.
So it seems like one of the big challenges in thinking about, when merging EIPs, what impact they could have on, zkEVM implementations is it's very difficult for people, working on those EIPs and thinking about it to understand fully what the impacts can be. So I'm wondering if some, set of guidelines or, I don't know, not rules, but something that could be used to help people understand what the implications are would be useful.
So that's a nice question. One of the things I would say it's important, and I think we did something kind of along these lines with the EVM team, was when they proposed the Ethereum Object Model EIP, they came to talk to us and they basically asked us how bad this can be, how can we make it such that it's not a big deal for the EVM to be implemented in, but at the same time we can move forward the proposal. In general, I understand that the knowledge on circuits, and especially on zkEVMs, is kind of hard to find, and there's really not a lot of people that can provide good opinion on it or like really expert opinion. One of the things that I consider will improve that situation significantly is if people that is actually developing these kinds of things like zkEVMs and these kinds of circuits can actually get into Ethereum Magicians Forum or ETH Research Forum and in EIP discussions actually argue about those things, but from the other standpoint, which is not only the utility that the EIP has or the errors that it might have, but also how bad it will be for the zkEVM to include this feature inside of it. That I understand opens a new, different paradigm on analyzing EIPs, and I understand it's hard because a lot of times we want these utilities and Ethereum needs to have a lot more features, right? But it's really up to us to make it easy to have this proof of validity later and not make the same mistakes as we did with RipND or Blake2F, which at the end no one is using, but we yet have the trouble to deal with them.
Okay, we've got one more question.
So how bad would an EVM feature need to be to the ZK world before we should consider not implementing it? What level of difficulty in a ZK EVM is acceptable and which would be bad?
For me, the best example was the EIP that proposes to include Poseidon hashing, because here it's just madness. So you have Poseidon can be configured on a lot of different ways, can have a different width, can have different number of rounds and different security parameters, but it's also tied to the field that you use. So I cannot tell, I don't know, Starknet or Polygon or whoever is using Poseidon hashing a lot and using Starks, I cannot tell them, yeah, this specific instance of Poseidon, we will merge it, but the other one that someone else is using, this one we discard it. We need to support everyone. If we include Poseidon, we need to include Poseidon for everyone. And that's lots and lots and lots of circuits and lots of different things that we need to handle at the same time. So even it might be doable, and I'm not saying we cannot do it, the question is, are we really prepared to onboard this problem on a way in which the result will be good enough so that the time spent on it is worth it? For Poseidon, I definitely think this is not the case. And it's sad to see, but until we maybe don't see some improvements, EIPs like this one are really, really, really bad to deal with.
Okay, I think that's time. Please show your appreciation for Carlos.
Thank you.